Right. So, as I say, what we're going to do is put a staff on here, one of them staffs. And these move up and click into place, all right? Yeah, so it continues 1 meter, 1.1, 1.2, and continues up. So remember, when you're picking them up, that you extend it and make sure the buttons click in. So I'm putting that over there, right, like that. I could have a level bubble on it to make sure it's truly vertical. It's pretty good that way, and it's not too bad that way. I'm more critical about this way, because anywhere it's out of adjustment, the readings are going to get higher when you're looking through there. So you're always wanting to achieve to read the lowest reading. Where's it? Sorry, that's a level staff.
Does it matter that it's like that?
Well, if it does. So this one, the button should come out and that's fixed. If you're leveling for anybody, and you're sighting the instrument, I'm on the point, and you also want to remember to check the bottom of it, because it quite often gets bashed. So if you got a nail sticking out the bottom, it'll be domed. So when you're on a station, you're trying to get it to millimeters, it'll be up the dome. When you go to a flat surface, it'll be on the edge. So it could be different. So if you're introducing errors, that's where it could come from. If I'm on a point and you're on the level, how do you know it's totally level? You can get a little bubble that sits in the back of these, and depending on the adjustment, that one hasn't got one, I've got one upstairs. Again, you're relying on the accuracy of the bubble. It may or may not be right. So the only way you can achieve it properly is move the staff slowly through the vertical. And the lowest reading that you get will be the correct reading. That's when it's truly vertical. All right? Because if you think on it, the readings are going to get higher and higher and higher until they disappear. All right? So it's always the lowest. It's not too bad of it that way, but certainly that way. And what you don't want is your staff band to go like this, because it's not going through the vertical. He's only going to there.
Levels on?
Sorry?
Why don't they design levels on?
Because people break them and lose them. So if it sticks out a little bit with a bubble on it, it's quite easy for people to knock them off, and then they get some and think, oh blimey, I can't level it because I've not got a level. Alright? Just watch the wind, that it doesn't blow off and bash somebody, which it did do the other day. Yeah.
I always find it really hard.
Right. The way that I've got it in there is, I'll show you them in a minute, is you'd move them two, and the bubble will move the direction of my left thumb. So once you've got them two lined up, move it 90 degrees, use the left hand, level it up again, and again you can find adjustment. And when it's in close, that's fine. Alright?
Yeah, that looks so easy.
Yeah. Sorry, that's an automatic level. Alright, and this is the circle I was talking about. So you can adjust that and set it as 0, and you don't touch it again. But to level it, you've got it in your notes, you'd get it adjust between these foot screws, level it so that the bubble is central on the line that way, and it'll always move to the direction of your left thumb. So if you're pulling it back, the bubble will go that way. If you go that way, the bubble will go that way. Then move it into there. The bubble needs to come this way, so my thumb needs to come towards me.
Wow.
And you're out of adjustment, all right? You want to feel that this tight, all right? There's no more adjustment.
No more.
Right? So what I need to do is bring these ones down, and they're out of adjustment as well. God, there's not a lot on that. Oh. Wow.
Oh, have you tight?
No, it's all right. It's all tightened up. I did this one.
You've done that right.
Yeah.
What's the
Right.
active?
There you go. So that one's take off the thing, otherwise you'll not see anything through it. So that's now level. So we can do the same on this one. Right, so you would have it between there and there. Move it there. Bring it round that way. Move it this way so the bubble goes that way. It's got my thumbs moving this way.
How are you deciding where to
Whoops,
move
and
it?
that's what you don't do either. Kick it after it's level. How am I deciding where to move it?
Yeah.
Well, because if you want to know, you want to get it in the middle of that, right? So if you use your two thumbs,
Yep.
if you go that way, the bubble will move that way. If you go that way, both out, the bubble will move this way.
Oh look, there's a little mirror of
Okay.
it.
All right? You can practice
The dentist.
and see how he does
And
it.
then you just put it in the right.
Oh yeah, it is good.
Okay, so it's going left,
Yeah,
and now it's going right.
yeah, because that's the way this thumb's going.
Quite literally built.
Yeah.
Got a little
So
dentist
it follows
so you
this.
can
your
see
Yes.
the bubble.
So when you get it in line in that way,
Yeah.
you line it as you've done, right? When you want it to go this way, you use this, and which way do they want the bubble to go? That way. So therefore my thumb must move that way.
Okay, so I could just, yeah.
And you can use all your fingers and just do it really, really fastly. Yeah?
Yeah, okay.
Okay? That makes sense. It does, right. Right, so booking boards. Where's all your booking boards? Is that my one? That's my one, right. So, right, if everybody grabs, there's 4 booking boards. If you want to do it as well, you might want it, because I can see you look like you want to do something. You could give that to somebody and I can give you a bit of paper.
Okay. Who would like this one?
So somebody has that to book down the notes. What we're going to do is I'm going to,
Would anyone like that?
yeah, come on, take us.
Okay, Val, come on.
Right, so what I'm going to do is, once the levels are set up, you don't want to be touching them because they've got a level and you need to level it, right? Likewise, when the staffs are set, you don't want to be touching them. So the concept of booking the sheets, you've got a staff point, which is identified, A, B, C, 1, 2, 3, whatever you want. You've got remarks over the other side, which can mean top of steps, bottom of wall, whatever. Your back site is where you've come from, or the start point. Intermediate site is where you take shots on the corners of that seat there, and manholes and intermediate points, but these don't have a check on it. So if you make an error in that, there's no way of checking it. Then you get a foresight, which is where you're going forward. So you'd back sight on that staff, do some levels, foresight on that, then the instrument will get moved. And then you sight back again, take a whole bunch of stuff, go forward, and work your way around till you come back to the start. And that becomes a closed loop. And you can add up the back sights and the foresights, and it should be 0. If they're not 0, you've made a problem. And I don't know if you can remember when I was talking about the guys with 70 mil out, the leveling, they spent ages trying to suss it, because they came off the step on the set entrance to the school, came to that station, and started and finished on a different point. And it took me a wee while to suss out that they didn't do as everybody else had done, which was started and finished on the same point. They started and finished on a different point. And it's 70 mil different, so the leveling was perfect. And we only sussed it out at the end. So you can start and finish on any known point, providing you know what the difference in level is. Because when you add up the back sights and foresights, that's what the results you get. If it's wrong, it means your staff man's not holding the staff level, the instrument's not been set up correctly, or you've booked it in the wrong place, or you're reading the crosshairs wrong. You always read the bottom one. Sorry, the middle one, not the bottom one. The middle one. And some levels have got a button on them that you press to get the prism and the wire to move. Can you hear that little rattling? Yeah, that one's louder, right? That is the prism on the wire, and it's called a compensator. And the line of sight comes through, goes through the prism and goes out. And that floats because when you turn the level around, that bubble that you've originally set up might be slightly out the wrong place. So because it's an automatic level, it means that the compensator, every time you swing it around to take something, it's automatically correcting itself to be truly level. As I said, some of them have got a button on it. You can tap it, but I prefer to use the button, the foot screw, and just flick it back and forward. And the object The visual object should float and then settle. And where it settles, you want to read the lowest point.
So the bubble doesn't necessarily mean to be bang on in the middle.
It doesn't need to be bang on, but it needs to be pretty well close to it. But you don't want to obsess yourself about trying to get it exactly right. And how you read the stuff, I think on your notes, you've got one of the next pages shows you what you're going to be looking at. Yeah. So this is what you're going to look at. So you can read the meters, you can read the decameters, which is from there to there, and you can read the centimeters, which is the little boxes, all right? And then you interpolate the millimeters, right? So you're reading to millimeters. Oh, yeah, this is what I was worried about. That one's all right. Scrap it. Right, so what I want you all to do is split yourself. I think there's 15 of you, so 5 can, 3, 5, yeah, 5 into that, 5 into that, and 5 looking at this one. And what I want you to do is one person reads it, remembers it, then the next person reads it, remembers it if you can, the next person reads it, remembers it, the next person reads it, remembers it, the last person reads it and books it down. And then at the end we'll ask each other what the value is to see if we're reading it correctly. And if you can't, then we'll redo it again, all right? So I'll read this one. So we're saying this is the back side, this is where we're coming from. So you move it the way. And you've got to adjust the crosshairs so that they're clear. And everybody's eyes are going to be different. Right, so you adjust them so that they're clear, but they should be pretty clear for everybody. Then you adjust the focus, which is the big knob, and then you get slow motion, which is the other one. All right, so again, you can tap it, it'll vibrate, but I use the foot screw, quarter a turn back and forward, and it'll settle. And that is reading, I'm not telling you.
Would you like biscuit?
No thanks. And what you want to do is right on your staff point, right, what you're doing, looking at him.
So get away. Oh.
You need to turn it round. And you can use the gun sights and use this up the top. Obviously it's a bit high for you. Line it up, and if you can't see anything, use the focus to get it in line.
So what, you tapping it?
So you're matching up the top bits and the cross.
There against in the middle of these. But then I'm adjusting the crosshairs so I can see it, and then it's nice and clear for you. So if you try the focus, try the slow motion, and try tapping it, or try moving the foot screw a little bit back and forward, and see the image move. All right. You got yours?
142.
Now you're meant to keep it quiet because you don't want other people to cheat.
Sorry.
All right, because we want to make sure that people can understand what they're looking at.
Sorry, do we move it up or down?
No, it's all right. You get 1-4.
Ah, sorry about that.
Yeah, but you've not written it to millimeters, have you? So you've lined it all up from there, which is good. Your crosshairs are good. Did you tap it, or did you move it? Right. So you can move the foot screws just back and forward like that.
Yeah.
And the whole image will float up and down and come back to the side, all right? So.
Do I need to write this?
Yeah, no.
I write in my book. So
If you write it down, hide it so nobody can see it, because I want them to see if they understand reading it properly.
Okay.
But watch when you're moving between it, you don't bash it, so that because if you hit the tripod, we need to redo it. And then what we do is we ask the other lot what they've got. Yeah, but that's not to millimeters.
So that's a back sight.
That's not. No, you're meant to be reading that. Yeah, because this is the back sight, and we're going to go forward to there.
Oh, sorry, that's the
Yeah.
first point. That's
Yeah, no, yeah, because that one's pointing that way. These ones were pointing the wrong way. Sorry, we need to be pointing this one.
Okay.
Because this is your back sight, all right, and this is where big mistakes get made. All right, so that one's a wee bit bent, but you can still read it. So you're interpolating where the millimeters are. Yeah, go on.
1.15.
So again, you should be reading this because this is our back sight. All right. Sorry about that. So you need to redo it again. Mind your heads, guys and gals. Woo. Yes, you do. And you don't want to be shouting it out.
What's the intermediate side?
Sorry?
What's the intermediate side?
You've got
The far side and the back side.
intermediate sights are just levels on the corners of the steps, top and bottom of steps, on the corner of that, the corners of the buildings, stuff you're not changing on. The back sights and foresights are generally on change points or control points because you prove them. With intermediate sights, you can't prove it. All right, but it should become apparent when you go through it. 1.5. So you can read that one again. Is any 5 finished reading yet?
Yeah.
You've all read them all, have you?
Oh no, just that one.
Yeah, that one, yeah. Right,
That's what we got.
1114. Nah,
No.
nah. You must be reading. You've got to read the centre here.
Yeah.
Right, I'll have a check again then.
Confident reading.
So confident.
Level.
What does that mean?
Level to the ground.
It's the relative distance from this, which is the collimation height. So what the difference in this is to what that is.
You need to know this distance.
Well, you do if you were using it with angles and distances, but you don't if you're doing this exercise. All right.
Oh, sorry.
You got it?
Yeah, I got that now.
So what were you reading then?
I don't know. I just got a little bit wrong. I just got a bit confused. 1 point.
Right. Did you check the other ones? Right. So what your rest of you reading on this one? Whose 5 is on this?
I don't know.
You don't know. You're on the middle one, are you?
I'm on all of them.
1.414.
Yeah.
All right.
What does it mean if it's under the cube instead of over
I guess
the
this is
cube?
my 5.
Well, this is where interpolation. Do you see the sheet? Where's somebody with a booking board? Did you see how they read it all? So you read. So you're reading the decimeters from there to there. That's the decimeters. Then each cube is a centimeter. So you get 1, 2, 3, 4, 5 is always the top of the E. 6, 7, 8, 9, and then the whole meters. And you're interpolating the cube.
Tops of from the tops of the, yeah, it's always from the top point.
Yeah. All right.
1.44.
Yes.
You get the
No.
level of where the stick is,
Yes.
and then you move the stick when you want to know the level of another area.
Yes.
But this one says a slightly different reading to the one that's there.
Yes, because they're all at both at different heights. So I've taken the shots on it so that because this is the start of an exercise to prove whether the levels are accurate. So this is just a checking exercise at the moment.
Yeah.
But the principles are this is how you go about leveling. It'll come to me. Don't worry. Just take it things in. All right. So. But, yeah. So what we're going to read that is a back sight. Then I'm going to read forward. Then I'm going to move all the instruments right close to that.
Yeah.
And then I'm going to read that again. And it's going to be difficult because it's right close.
Yeah.
And then we're going to read that one as a foresight, as if we're going to go forward again. And the difference is, because we're in the middle, there's half the error. When we get up there, it's how many? It's 30 times or 25 times the error, because you're close.
Okay.
So you've reduced the error there but increased it there because of the way that the level
And
works.
then what do you do with an average?
Well, then you add them up and you'll get a result,
Yeah.
and that'll tell you whether the level is an adjustment. If it's out more than 5 mil, then the level will need adjustment, and you would set up, you'd adjust the main crosshair to read what it should be, right?
Okay.
And then to prove that, you would sit in the middle and do the same exercise again.
Okay. So you're checking that you're correct.
Yes. Yeah. Right, so what did you get on yours?
That. Oh, with the other ones.
No, on this one, 1.4.
1.4.
That's what I got, all right?
Yeah,
Okay. So now you want to read this one, which is your foresight, is before you move the instrument. What?
1.55.
See the line?
Is it a bit twisted? Right.
How do you focus it? Is it not? No, I got that, but what's it for?
Right. So what did you read?
1.55.
0. No millimeters. Yeah, that's what I got. All right. So immediately, first reading. Now spin it round and read that one, which is your foresight. Right, but don't touch the tripod. Right, what did you guys get
This
on this one? You reading this one?
Yes.
What did you get?
1498.
1497, so 1 millimeter, which is fine. All right. So, you understand the reading on that? You must have done, because you got it right.
Yeah.
So now we turn the level round. You sight that one, which is the foresight.
What I was saying though, that I don't really get you, because basically, like, if we put like our level in the garden and we put our stuffs around, correct? Then we took all these measurements, yeah?
Yeah.
So basically, like, what happens is if this is the level and this is going, so we have the stuffs and then we have all the
That's right.
reading, yeah?
And the intermediates will be the difference from there to the ground. This is a collimation height. So
Alright.
that gives you the difference in heights.
Well, the thing that I don't understand is that, like, all these measurements to me, they only make sense in relation to this height.
But that's what you find, because if this was a control point, you wouldn't want everything relative to the control point of your datum. But this exercise we're using to check the level. We're not using it to do any leveling.
I see. So you want to know if that point is higher than that point, and that's it.
No, I want to know if the level is reading correctly.
Right, cool.
And I'll explain a little bit. So now you turn that
this is
level round.
calibration.
Yes. Turn it round, you read that one. All read it and make sure you're reading the same thing.
Now makes
And then
sense.
we'll move the instruments
I thought
and
we
we'll
were
go through the
already-
exercise again, and then it'll make a bit of sense.
I thought we were already
No.
taking.
Not yet.
Right. Good.
Not yet.
Too enthusiastic.
We have a professional verdict.
All right. Well,
looked at the bottom right. Yeah.
oh. Have you read it?
Yeah, I wrote it down, but now I look again and now it's different.
But how much different? A millimetre? No, you're meant to be reading this side. Oh, wait a minute. Oh, you're still doing that one? Yeah, on that one you should have been reading 1497.
Yeah,
You're miles out. What do you got?
I feel like I
153?
can read it though.
153. Yeah, because you're reading the top hair. There's 3 hairs. There's the little bottom hair about that length. And then there's a big one that goes right across. There's another little one at the top. So we're reading the level, which is the big one in the middle. Yeah.
That's 1498.
1.498. You're 1.4, which is the bottom. Then you get 9, which is the last square, and it's 2 or 3 millimeters to the top. So I've got actually 1497.
Oh, right, well.
So book that in there as point A. 1498 is the back site. And then we're going to put B in there, which is the one that you started on originally. We're going to read whatever it is on there. So we turn this round, yeah? One, two, three, six. You read this one?
Yeah.
What'd you get?
I thought, well, I got that.
286.
286.
Yeah, perfect. Right. Right, so you should have been writing A.
Oh, sorry, there.
So you want A, which is your first reading, then B, then A. So your A goes, whatever was the first reading.
1414.
1414, yeah. And then you're reading forward to B, which goes in there, and that was your
1285.
12, yeah. Right? And then we'll move the instrument just in front of there. All right?
Yep.
So,
Why is there ABA?
because we're sighting A, then you're sighting B, then you're moving the instrument, and then you're having a back sight to that one first, and then to there. Because if we were going to go round the corner, you would sight on there, sight there, you'd move the instrument round the corner. You can't see that one.
Yeah.
So you'd see that one, which is your back sight, and then you go forward and continue all the way around the building and come back to that and add them up. All right? So to move the instrument, make sure it's clamped up under your shoulder, hold the legs, move it forward, put it into the grass. You want to be about a metre in front of the staff. Don't touch the staff. Put the level in, level it up, and then you'll read back into there.
Okay.
Do you think that reading is correct?
So you head forward. I haven't read it. Let's see what you've got on there. 1369 I would do.
Oh, really? Oh, okay.
What did you get?
70.
That's all right. Within a millimetre's fine. All right. So is anybody else reading this instrument? Or are you on your own?
Is anyone else reading this instrument?
Oh, you.
I'm reading this and that.
Right, you need to read it to find out what the levels. See if you can understand reading it. Right, you've read this one.
Yeah. Jalen, move out the way.
Get out the way.
1, 4.
What'd
you get? One.
I found 1422.
1421.
So would that be wrong reading?
No, it's fine. No, because it's an interpolation. It's what your eyes you think it is, whether it's one above or one below. So it's fine.
Isn't there any like of these things where it's more precise?
Yes, you can get ½ centimetre staff, and it's lots of lines. And when it's close, it's easy, but when it's far away, it's much harder to read. All right, so these are the best for general work. If you look at the backs, is it this one? No, on my staffs I've actually got ½ centimetre readings, and it really is too many numbers.
Yeah.
So this is easier. All right. So you've so far read your back side correctly, your forward side correctly. Now we'll move the instrument. Sorry?
What's this one?
That one was reading 1369.
I keep looking at the lower line every time.
Yeah, and that's what you got to do. So the little lines at the bottom, that's where you get the distances. And we'll show you how to do that later. So the little bottom one is the bottom here, the top one is the top here, and the main one. So if you read the bottom one and read the top one, take one from other, it'll give you the distance from there to there.
So clever.
Yeah, very clever. Right.
Okay, so that's 16.5.
Have we read this one?
1.43.
1.43. 1.43.
I say 1.42.
1421. Yeah?
1.21.
And what did you get? 1423, did you say? What did you say?
I just said 142, but I didn't. I know it's a little bit above 142.
So you need to interpolate, is that millimetre above?
Yeah.
Is it 2 millimetres above or what? So I had 1421, all right?
Yep.
So that's fine, all right? So now we move this close to there. And what you do to move it is you make sure it's clamped up, put a shoulder underneath it, and just carry it forward. All right? That's it. And I'll do this one.
So you have to go.
Yeah, that's fine there. And try and get the top of it as best as you can level, and then level up the bubble. All right.
Okay,
So-
so I'm sighting off the back.
You're citing that as your back sight, yeah. And have you written down A and B?
No.
No, you haven't. Right. So you need to write A was your first reading. Do you know what that was? So write A in there. A, B, and A.
I've forgotten them all.
Have you? All right, I'll help you.
Yeah.
Right. So you got A, B, and A. So we write back to that one, and this was your level, was it, or this one? This one. So that was the building. So you read forward. Well, I had 1.550. All right. And then I read forward to this one is 1421.
Yes.
Right. Now we're going to read back onto this one, and you're going to write it in there, and then you're going to read it forward to that one and write it in there. You're going to add up the M2 and add up the M2 and see what the answer is. All right. Yes. No.
Maybe.
Right.
Wait a minute.
No, you're reading. No, you're reading this one first. You're just reading back to that. No.
I don't know why to get the bubble to move into the middle.
All right. Right. So pull it a wee bit back from these guys because you don't want to. So if you try and get the whole lot level to start with,
Yeah.
and then the bubble's too far this way, so I want to
Yeah.
go that way. So I can go like that with 1 foot screw, and if I'm using all 3 foot screws, I can get quickly on just chase it around and get it in the middle.
Sorry.
All right. So if you go to the what's in the handouts, what I showed you, it was that way, and then that way. And you can do it.
So you're just twisting one at a time.
Well, you're twisting these two together to get the
Yeah.
bubble to move that way, and then that one to bring the bubble on the perpendicular.
David,
Right.
how come we're doing it at this point now?
So you got A. Was that sight? Yeah. So
Yeah,
write
yeah.
A in there.
Yeah. So that should do
That's
back.
B. No, that one should be over there.
Yeah, it should be there, shouldn't it?
That 1422 should be over there.
Yep. Yep.
So get rid of that, and then A back onto this, and this is what you're going to read, which is going in there. Then
Okay, so what is...
this is your back sight onto this one,
Okay, why are we doing it here? Well,
because we're going. This is going to exaggerate the error. This is us checking the instrument to see if it's in adjustment. I'll show you in a minute.
Okay, but in practice, would you do this? You'd go over there,
In
wouldn't
practice, you do it first. On the start of every job, you do it because you'd want to know if you hired the kit
Yeah.
or you bought it. You'd need to know A, was it any good to use.
you? Okay.
So you do this once off, and until you got familiar with it, you do it probably start of every job. But if it's in the back of your car and it's getting knocked about, then you would do it as a check to make sure it's reading correctly. But once it's okay, then you're quite happy to use it for days on end.
Is that point A?
That's point A, yeah.
That's point B.
Yeah.
And then we're looking...
So once you read on to B, then you sight back to point A. You add up these two, and see what the figures are.
All right.
All right. Oh, sorry.
David, I don't understand. I'm a little bit lost. I don't understand why we've gone from. Why are we here?
Right, we're trying to find out the accuracy of the level.
Yeah.
But it's an adjustment. So if you set up in the middle, you've got the same error both sides if it's reading high or low. All right?
Yeah. Lewis, he's explaining to me why we're doing it now.
Yeah, done. So when you move it over here,
Yeah.
the exaggeration is minimised at this site,
Yeah.
but exaggerated in that site. So when you add up the back sites and the forward sites, you'll get a figure, and that will show you whether it's right or wrong. So you're a bit premature in your question. It'll come.
6, 5,
It's just it's so close, it's hard to
6,
see.
5.
Should be easier to see.
Well, yeah, but it's like really close. You don't know which cube you're looking at.
That's right. And if you look at the video, I get a big stick because I've only on myself, and I'm trying to get a stick to find out where it's pointed.
Yeah, no, 1 point.
Because you don't want to get it wrong.
1.42. Everyone's saying 1.42.
Oh, blind. 1 4 1 4 1 9. 1 4 1 9. Right, what did you read?
1.420.
1 millimeter. All right, it's good. So now you spin it round. Somebody's cheating. So now you spin it round, you sight that, and that goes in that back column. All right.
So hold on, which one are we spinning around? That one.
This one is going to point on there. Yeah. So that was your back sight. This is forward, as if we're going to move forward again. Right. This one. 438. Right, who read this one? Anybody?
I'm reading it.
You're reading it. Oh. What did you get on there?
1439.
1438. So 1 millimeter is fine. Now you want to read forward to A, and that book's in there. All right. So
Sorry, where do I put that? So I've got this.
that should be up one because you read this B.
Oh.
So put a line through that and put it in there. And then the next reading is you're looking forward as if you're going to move the instrument that way. So that's going to read in there. All right. And then add up the back sights and add up the forward sights.
It's so close, I can't see where the.
Well, you can get somebody to hold a finger on it.
You have an idea?
I can't, yeah, but what do you mean? I can't tell where the bottom line is, so I can't tell how many squares up I am.
What have you got, Hattie?
Right.
I haven't found
Do you have a look?
Yeah.
See what I mean?
Excuse us, lads.
Sorry.
You kicked the tripod. You shouldn't be doing that. You need to be careful.
I mean, that's what I.
That's the problem, right? So you get 1 4 as you said,
Yeah.
and it looks like 1 4 6 something, right?
Yeah.
So it's there.
Yeah.
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 1.465.
2 millimeters. I get 6 7. All right.
Okay.
Right. So what was you reading?
1466.
1 millimeter. That's 6 7. All right. Fine. So now you point forward, and you book that down into the foresight to A.
Right, I see. We'll say 6 7. Well, whatever you want. And then you spin it round. Ready to have a look?
David, sorry. Give him a second. We were wondering where our next. So if you had that back sight, where
Yeah.
does that go?
So you read first one there, second one here,
Oh, it's first one there.
next one there because
yeah.
you're reading back onto this one. So that should have gone in there, the last
Yeah.
one. And then the last reading, which is sitting forward, goes in there.
Okay.
All right. And this is where in the video I made a mistake after 50 years and got them the wrong way around. So it happens. And you just got to be careful. It's where you're
What
going
did you
forward.
get?
For this one,
Oh my god, we got the
1.547.
7! The same!
All right. I'll have a wee look. So you're making sure it moves up and down, yeah? 1547, yeah?
Yeah, nice. Nice work.
Right. So Right, so you've done this one?
Yeah, I believe so.
Right, so we got 1565, let's see what you got.
There are kind of themes, yeah.
1566, I would say.
And then that gets written in this one, right?
Yeah.
So that's a four
That's
sight.
it, yeah.
So that's a back sight, the four sight. And then what do you do from there? Do you have to work out the difference, or?
No, you add up them two and add up them two.
Okay.
So it goes in there and there, alright. So I've got to read this one first. Let me read that one. Oops, sorry. 1592. What did you get?
Adding up.
So 3 mil. So I'll have another wee look at it and see if it should. 9.3. Put 9.3. Alright, so now add up them and see what you get. Alright? So everybody's adding up the back sights and four sights.
Four. Oh, is that the error then? Is it?
No. Well, I'll show you in a minute. 5.
3016, 3017.
For both of them?
Yeah.
Okay.
So
What does that mean?
that one is perfect. So which one are you reading? This
That's
one?
this one here, yeah.
Yeah. So it's a building one. So 7, 6.
Should be level this time.
3, 9. That one. So I reckon that level's 4 mil out.
I got 1 mil out on that one.
So you got 3017 and 3016. All right. Because we got a difference, either I'm reading high or reading low.
Yeah.
All
They
right.
didn't divide it by
But the 4 mil,
No, just added them up.
you've got 1 mil. You would never adjust it.
Yep.
I've got 4 mil. Borderline. If you get 5 and over, you would adjust
How
it.
would you adjust it?
I'm going to show you.
Okay.
So if you take off this piece,
So we're essentially just calibrating.
yeah,
That's all we're doing.
in there you get a little adjustment, right?
Yeah.
And you adjust that to move the crosshairs up and down.
Okay.
And if I had to do it, so I said my 4 mil is no good,
Yeah.
right? So what I would do is, because I can only adjust that reading, I can't adjust the previous because they're history. And I want it to match that one, right? So I would need to bring it up 4 millimeters so that it matches that.
Okay.
So I would adjust it so that the crosshairs come up to reading 3.017. Sorry.
Yeah.
No, I add 4 onto that, so I get 1.596. Right? So adjust that reading, so I read 1596 by bringing the crosshairs up.
Yeah.
Put this cover back on it and redo the
Do it again,
exercise.
and if it comes
And if
out-
you come up with 1 millimeter, it's
Yeah.
fine.
Okay.
But you only do that if it's over 5 mil or more. No,
So you bring that one up to match.
because I've done a difference. I've got
So between this one and that one, there is
no. We're only talking about this. So I've added up the back sights and I get 3017, right? That was my first reading. That was my second reading. That was my third reading. That was my fourth reading.
okay.
All right. The only one I can adjust is my fourth reading. The other ones are history. I can't get back. So this is what I'm saying. So as that combination was 13017, this one is 4 millimeters short. So the only way I can get it to agree with that is to change that last reading to read higher. So when I add them up, it's fine. Right. So we'd adjust that reading, and it's 15. Well, it's gone now. Yeah, it's 1592. Whoops. So what I need to do is adjust the crosshair so it brings it up to reading 1596. Right? Put this back on there, and then redo the exercise and prove that it's all right. And if it's all right, it's fine. But this level is fine. It's an adjustment. All right? So this exercise is purely to make sure the levels are reading correctly, right? Because if the compensator sticks, and that's this thingy here, then this exercise we've done it would be pants, you would get silly errors, 10, 20 mil error. But because it's only a few mil, it means the quality of the level is good. All right, so you've done it. So this is a 2-peg test it's known as, and this is purely to check the accuracy of the instrument. And you would use it once a sight, or if you bought the instrument or you hired it, you would do this exercise before you ever used it.
Right,
Because you need to know if it's any good.
Yeah.
Once you've proved it's all right, then it's fine to work and carry on working, right? So I'll check these two, and then I'll show you how we can take the distance from here to here. All right.
So if this is your result, you would say that.
So you're 3 mils, all right? Which is
that's
fine.
acceptable.
It's fine, yeah. All right, so it's good. So you read it fine, it's all good.
It comes out perfect.
All right, what did you get?
What?
The back sights and the foresight?
10. Get here.
Right, so what did you get for your not your back sights and the foresights?
Back sights 1 4 1 4 1.
No, you add them up.
Oh, I see.
1.834.
2834.
Yeah, 2.834.
I don't know, add it up. It's 2 figures.
Yeah.
Yeah.
This is proper primary school.
Right, yeah.
You've got to
And
draw
there.
a line and do the little plus sign.
2.7.
No, 2 point.
Start there. 7 and 5. It's 12.
12.
2 down, carry 1.
Carry the
Carry
1.
the one.
Oh my god, okay. Right, carry
Cool,
the 2
13.
down.
So 2 3.
This is painful, isn't it?
2.832.
Right, so 832 against 834 is 2 millimeters
Oh, that's
different.
good.
Which means the level's an adjustment. If you need to adjust it, I'll show you what you do.
Do you want it bang up?
So if you had to adjust it, you undo this.
Yeah, he definitely did.
Right, and that little adjustment there, you would get a Tommy bar and it adjust it and it moves the crosshairs up and down. All right. So let's say that you had more than 5 mil, 10 mil different.
Sure. Move it by
Because
1 notch.
yeah, because you've read that and then you've read that and then you've read that and this is a final reading.
Yeah.
You need to get this side to match that side. So if this was 10 millimeters high,
Sure. You would,
you would need to reduce it so that it comes down. So you would read 1547. You would need to bring it down, the crosshairs down to 1537.
Yeah, I got you. Nice.
And once you've adjusted it, you then set up in the middle, do the whole exercise again, and it should be 0.
Wow.
And when you've
Okay.
got it, you know it's good. But this level's
But you have
fine.
to set it up exactly where it was.
No,
last.
not exactly.
Oh, no.
Just in the middle, because whatever you're reading depends on where the height of this is. Right? So
Oh, true. Oh, got you. This was just to calibrate this. So we did this just to calibrate, so it doesn't matter where it is. If you do the readings of each, you can then adjust it so that it reads this.
this is only to prove that the levels are good because nobody's ever checked them. Right? But we've checked the fine.
So point 002 is okay.
It's fine. Anything under 5 mils fine because you might read it wrong by a millimeter back and forward. So you've got to accept a few mil by your human error.
I got you, but 10.
But if it's over 5, it means it's probably the instrument, not you.
Okay.
All right.
So it doesn't matter where you place them, as long as they're.
As long as you're relative. So we use that as the back sight. We can do a lot of leveling. Foresight, we'd move the instrument, sight back on that, and continue leveling.
Right.
Is this the exercise over for now?
No, we're going to do a little bit more. So what we're going to do now is how do we read a distance from here to there? And you can use one of the tapes to get it. So if I read that now,
Lewis, watch out.
right? And if I read the bottom here now, which is, yeah, that's just circle. That's
Does that matter? It's not 0.
no,
Oh.
because that's if I was using it for reading angles.
Oh, sorry. Yeah.
And that's what I'm saying. You can only read to 20 minutes accurately, but it's good enough.
God, you can read angles on the thing. I was wondering.
Yeah.
You might need a protractor.
No, you will if you're drawing that out.
Drawing it, yeah.
Makes sense now. Right, so I'm reading 145. The crosshairs are not in. I'm going to leave it because obviously you guys have adjusted it. But it's 1453, say. Right? That's the bottom here. 1638 is the top here. Take that from that, 5, that from that side, that from that's 1. That should be 18.5 metres from there to there. Try it. This tape's there.
When you feel like that's something is there, where do you measure it?
Well, it's underneath there. So if you put a plumb bob down, that's where you'd measure from. It's a little weight on a bit of string, and it can get its centre over the point. All right. And that's what you do if you were setting over this nail. You would set a plumb bob up, get it special, and then you can use the angles to take the distance and the angles, and you can easily plot it
The
up.
distance from the centre.
Yeah, centre as best you can. Yeah, but if you take this, you can only read to 100 mil, so there'll be fine. All right, just watch you don't bash your staff. That's all.
In the group, but no one wants to sing. No one wants me to sing on Derek.
Right. So if we were going to do 3 hair stadia, so you've got the circle, and that little line tells you what the angles are that you're reading, and you would set 0. But if you want to do a distance, you would sight on the staff, read the bottom here, which in your case is 1480, so 1480. Read the top here, which is 1652. Right? Take that from that, 2, 8 from that, 7, 5 from that's 1. It's 17.2 metres from here to there.
Wow.
Right? So have a wee look at it. So
How did you do that again? Sorry.
well, you take the bottom here, that's the bottom,
Yeah.
from the top, times 100.
All
Gives you
right.
distance.
measure angles on your?
Well, if I was doing it from here, so this is a station, I've set it up. I'll move this round till it reads 0, and then as soon as I move it away, I'm getting the angles. All right, but don't touch that. When you're over a station and you want to survey things, you don't want to be. You only touch it once. All right. But try reading the bottom here and the top here and taking one from other, multiply it by 100, it'll give you distance, and then get the tape measure to see what you get. Yeah. What did you get, guys?
We're going to try it again. We've got 8 metres, but it's not.
8 metres?
18. Right. I'm sorry, it's 18,501. 18,501, Jen.
Well, there you are. So we're looking at, can we get it better than 100 mil when you got it spot on? Because I had 18.5.
Nice.
All right.
Check it with a tape measure.
Right. So we're going to take the bottom here and the top here, multiply it by 100, and see what the distance is. All right.
So
1510.
So the line.
So where do we
what-
There's
where do we
another line
write
at the
this?
bottom.
Well, you could just write it aside. 16
How do you know where the middle is?
1677. So I reckon it's 7651. I reckon it's 16.7 metres from here to there.
So what am I reading? The top here?
You're reading the bottom here first, write that down. Read the top here, take the bottom from the top, multiply it by 100.
Is that what we got? Is that what we got?
Bottom then the top.
Yeah, right, so what's your bottom reading?
1510.
1?
1510.
Yes. And the top?
1678.
I got 1677. So
Okay.
I've got 16.7, which is the result of that, and you'll get 16.8. And that's what I'm saying, it's 100 mil different because he's read it wrong by a millimetre. And what you want to do now is you have a little go at it and see if you read it, and then physically measure it to see what you get.
Yeah.
These guys got its cock on. They had 18.5, they measured 18.5. So it becomes quite a powerful thing if you look after it.
It's a 16.8 metres from here to there. Okay, wow, that's clever.
And try it.
That's really clever.
And again, you set this on 0, and you can take angles and easily, quickly get distances.
Yeah. So,
So-
what you do is you take all your sites and you measure between them points, and then you get all of that measured as well from your pin. Wow.
Yeah.
It's clever. Want to go?
What distance did you get? Did it match up?
It did match up perfectly.
Did it?
What was it, Hattie? 1.72? 17.2?
Yeah, that's what I got.
Times
Yeah.
by 100.
What was it you did with those
I got
figures?
17.
Multiply them by 100. So whatever you get, multiply by 100.
Measure?
Can't you just remove the decimal? What do you mean?
So we measured-
Well, yeah, but what you're doing is effectively,
Got two measurements, yeah?
that's
got
at
the top-
16.8.
Yeah, no, I've just copied that for you.
All right, sorry. Right, so 8 from the zeros, eh?
What did you
This
said-
is the top and this is the bottom.
I've already
yeah?
so it's
No,
already been
bottom,
divided by.
bottom and top.
Yeah.
So I
That's
had,
the bottom, that's the top, yeah?
yeah. No, the other way around. Have the bottom there, 1510, and
Yeah.
the top is 1.677.
Yeah.
Take that from that 7, that from that 6, that from that's 1. Multiply that by 100, goes into there. It's 16.7. All right? Because that's the decimal point. So, all right, 100 going that way. 10 and 100, yeah. Right, so you're moving your decimal point twice. So it's multiplying it by 100. The difference between them is 1.67, right?
Yep.
Multiply that by 100,
Yep.
you get 16.7.
Okay.
All right?
Yeah.
Now get a tape and physically measure it and see if you get it. These guys have got it cock on.
Cock on, yeah.
Well, within 100 mil, because you read it by a millimetre, that's what you get.
Where's the tape?
Tapes are here.
Going for the diary.
So, makes it a wee bit clearer?
Yeah, so but you're always taking the
It's a collimation out. When you're
top
reading
number
through,
from the bottom number.
the bottom number from the top number.
Alright, cool.
All right? You'll suss it because when
Yeah,
you
yeah.
try and get the other way around, you just wonder what the heck's going on.
Yeah.
So we've done a wee bit of levelling to find out if the level's reading correctly. We've done a little bit of 3-hair stadia to find out can we get distances. The same idea with the angles. I set that one to 0, so I was sighting on the staff. So we assumed that this might have been over a nail. Set 0 on there, and that would move my back sight to the station, and then I could go forward, read distances, and do lots of detail. What do you got?
16.88.
8-8. 8-8.
That would do.
8-8. All right. So we're reading
So
the levels wrong.
the 1 centimetre difference.
No, it's a millimetre gives you 100 mil. So we've 2 mils. So the bottom one might be a mil low and the other one might be a mil high.
So is that close enough?
For levels, it's probably fine because it's flat surface. You hold a level there and a level there 200 mil away. Is it going to mark too much? Probably not.
So like this minus this is 167, 167,
Yeah,
and then you multiply by 100.
No, if
What do
you
you multiply by 100?
yeah, but that's 1.50,
I see what you mean,
1.67.
I see what you mean.
So that becomes
So
0.167.
you adjust to make meters, and then you check, and this should be the distance in between your level and the staff.
And it depends how accurate you're reading it. So if it's a millimetre high and a millimetre low, you could end up with 200 mil different. But ideally, it's about 100 mil plus or minus.
Okay, good.
All right. Okay. So what we'll do is we'll put these levels away, and then we'll try some. I'll lay out the tape. It's a bit windy, but I'll lay out the tape and show you how you would measure across obstacles. All right. And how we do trilateration. All right.
David, 1 second.
Yeah.
So we took the measurement and it's 1688
Yeah.
against 1670.
Yeah.
So what would you do now?
Uh,
It's like,
well, if that's your top hair, yeah.
but this is the measurement in between the level and the staff and the level.
All right, 1.88. So
And
we
this is the
1.7. So it's
difference,
18 centimeters different, yeah.
Yeah.
And that's what I was just saying to your man here. If you read the bottom one a mil wrong, and the top one a mil wrong, you could end up with 200 mil different.
Uh-huh.
And you've got 180 mil,
Okay.
so you're nearly 200 mil.
Yeah.
So it's plus or minus 100 mil. So even though that is excessive, it depends on the verticality of the staff.
Right.
And it depends on your reading, your interpolation of the millimeters.
Yeah.
So even though that seems a lot, it's still within the tolerance of your reading instrument. And as I said, it'd be fine for a level. If I was taking a level there, and we're saying, is it there or is it 200 mil different? Well, we don't know. It might be somewhere in the middle. So is that? It should be there, but it plots out there. Is that going to cause you a problem? In this situation, no.
Yeah.
If you were doing the corner of a pathway, then it might be, but you wouldn't use 3-hair stadia. If you want 500 scale surveys, yes, because it's accurate to 150 mil, so you're still on the borderline. And it's not critical, and if they're going to rip it all out, it doesn't matter. But I would use the 3-air Stadia mainly if it was a difficult site and you want to level traverse between your stations to fix them, so you could measure from that, or you were using it to level soft areas and flower beds and things like that. It's fine, because 180 mils not going to matter at all, and it won't be every time. You'll have it the same as these guys, which was exactly it was error free on their one. So, all right, yeah. So we'll pack these away, and then we'll do a bit of measuring. Take the level off first, yeah. That's it. And cool. I think that one had the. Oh no, it was this one. Yeah, no, this one had the cap, I think. Sorry? You probably can pick one up for about £150, £200. And you can do a lot with it.
Yeah.
You really can do a lot with it. Right, just leave them all here, it'll be fine for the time being. Right. Right.
Minus that by that.
Yeah.
To get that.
Yeah, but
times by 100.
that's higher than the higher number.
No, yeah, I know, but that's just the distance.
Oh, that's
just,
this.
yeah.
Yeah.
Oh.
Right. Right. That's it. Right. Right, class. Everyone. Right. So we've done a bit of leveling. We've done a bit of distances. Now you want to know a bit trilateration. So we've got a station there, which is a little nail. We've got a station up there, another little nail. I want to fix a bit of detail here. So I would first measure between there and there.
Should we do that?
And we're doing do that, yeah?
Do that.
And somebody's going to book it down? Or I'll book it down.
Well, is it obvious?
Yeah, I'll come up there and show you. Not the red one, it's a little one.
That one.
Yeah, that's it. So keep it tight. So we got
37. Oh no, sorry, 38.
point.
38.17. 3897.
Yeah, and it's almost right on the millimeters, isn't it? So 370, 170. Yeah, that's fine. Right, that's fine. Right, the wind wind it up. So that would be your base, all right? And then what we're going to do is measure the two corners of the ponds.
So shall I leave this here?
No, because you've done that. So we're going to measure from that end to that corner over there, and then we'll use that tape from the corner right to where you were. All right? We'll use a smaller tape for that one.
It doesn't matter.
Is it tight? Oh. All right. Okay.
Triangulate.
So we've done. That's the baseline, all right? So
Where the tape measure starts from?
well, if that's 10 centimeters, it's 0 at the end. There.
Oh, well, you measured it. No, look.
We did measure it. It looks like it might be.
I've just
Ready?
rolled it all the way out.
Oh,
We think we more or less did it right.
right. So it's at the end.
It's at the
It's
end.
the end of that bit.
Weird,
Alright.
isn't it?
Yeah.
Is it?
Because then you can't hook it
that's
onto
where you
anything.
Yeah, but
Bizarre.
then why would you have a hole in there?
Yeah, that's what I said.
Okay, so where did we who was holding it on? Where did we hold it on at this end?
I held it on here, which is about 1 centimetre wrong.
Well, all right.
We do it again.
So
be all right.
no, it'll be all right. It'll be all right. That. So we'll say that's wrong. So we'll say it's 38.1.
Ah, here we
It's
are.
less. Oh,
The man. It's there.
Yeah.
it's right at the end. That's
Yeah.
fine. Yeah. So we're saying it's a centimetre wrong. All right. So it's 60. It's less. Yeah.
Well,
Not 170.
a clever
Right.
version.
So I want to measure the ponds. So that's the steps to the ponds.
So when we're going to this corner,
Yeah. So we're going to there and that corner there.
we've got obstacles.
That's obstacles, right? We don't like obstacles. So we move some of the obstacles out the way, if you can.
Move your lunch box, Caleb. So do you want the corner here or do you want the coping stone?
Right where it hits the ground.
Yeah.
So we've got
10.10
Forward or 7.
1047.
10470. Yeah.
More or less.
All right. And then we want to do from that point to there. All right.
Yep. Hattie?
You go with the other point. Is it all the way over here?
Yeah.
This bench is the way.
No, it'll be fine.
Yeah?
Yeah.
Oh, you want it underneath?
No, it goes to this side of it. It's the way down there. Right.
Keep going.
And then effectively what we'd get is the baseline.
Yep.
You've got to mention there, dimension there, that point, this point's fixed.
Exactly where
accurate.
that'll be. Yeah, can't be anywhere else.
Yeah. All right.
Triangulation.
Trilateration.
No,
No, look at Wikipedia. But I mean, it's very similar things.
Just walk past it.
Oh, where is it?
Oh, I'll go. It's a little tiny hilty nail like that one. No, not the red one. It's this one here. Whoop, too far. Too far.
Yeah, it's that red one, isn't it?
Yeah.
Oh, that's difficult. spot,
All right.
to be fair.
So,
Lewis, pull it in!
so the proper 0 on that. That's it. Oh. It doesn't matter from there, as long as it doesn't twist too much.
So 37650.
37650.
Yeah.
So I'd have the 3 dimensions, trilateration, job done. All right.
Where she
8
is.
times
Okay.
3 divided by 2, that's your...
Hey?
You want? No?
Oh no, you just take them 2 measurements
Oh.
and then you fix it to your baseline, and that is the only place that can be. Is that
And
point?
then do we work out that
No, you don't have to. You could take offset measurements. You could go down the chain line and go off at right angles.
Are they called tyres? Is that right?
Yeah, but what I would do now is I would fix the other point. So I'd take that from the station there, and then along the face of that.
Okay.
And you got a whole bunch of
You start
triangles.
fixing points.
And then you can measure off that to points,
Yeah.
all right? And you start to build it up like that.
Alright.
And when we start doing it in earnest, I'll come out and show you what to look at.
So
When we do our survey, how much are we surveying at? Everything.
I've got sheets up there. It'll be a quadrant. So this is 4 quadrants, and somewhere between the one in the middle of the main point.
Oh, okay. Right.
So there's 4 areas. There's not a huge amount of detail, but as long as you fix points like this with trilateration from the various stations, which will show you where they are, it shouldn't go far. It shouldn't be wrong. It
so
should be
each
spot
group
on.
is going to be drawing something
So
slightly
this is
different.
triangle.
Yes,
Try
and then we'll check it against my master plan that we've
Do you
got
do
in
that
there.
with that end one as well?
Yes, you would.
So we shouldn't have bothered reading that in,
No,
but to get a point.
yeah, because that's what I've done there. So you do the same on that other end.
And this?
Well, you can do them too, and then run a chain line
Oh, you
through
wouldn't-
there and then offset.
You wouldn't even need to do that.
Well, you could
Just
do is
measure.
you could measure everything that way,
Yeah.
and then you've got a whole bunch of triangles. But your sketch is going to end up quite busy because you're getting all this
Yeah,
going on.
You don't really need
So
that.
then you want to tabulate it, so you can't point at number 1. So A to 1, 1 to C,
You don't want to
and you can write it down.
You don't want to be scared.
No, and you write it down in table form, so at least when you start drawing up, you know what's going on.
So as long as you have a triangular point to a main.
You're just forming triangles everywhere, basically. And the alternative is you leave that along the line of the roadway, and you measure at right angles off to things.
Yeah.
All right.
And we like right angles. We like right angles, don't we?
Yeah.
Yeah. How do you know the angles here? Should
You
we
don't need
take-
angles.
You don't need them.
No, because you get 3 distances. That distance, there's only one form, one shape it can go. It can't change. That can't change because you've fixed it by that
To
point.
draw though, how do you? Or
No, you do it with arcs. You do it there, protractor at that distance, draw an arc. Protractor there with that distance, draw an arc. Then you want to get.
Pythag. I've forgotten how to do a lot of that.
Yeah, you can work out what that is across there.
Okay.
But once you've fixed one,
Yeah.
you know, so if you're saying that's your line, that's fixed, that end's fixed, that end's fixed, you can then draw an arc on there to give you that distance. The arc across there. Fixed it.
Download the Pythag app.
Yeah.
Saving the time.
All right.
8 times speed divided by 2.
All right, guys. So what we did is we measured the baseline along here, right? Then we measured from that point there to the corner of the pond.
Yep.
And then we've measured from there back to the station over there. And you can do the same on the other side, so you can measure that. You've already got the baseline. And once you've fixed these 2 points on your drawing, that you know where they are, an arc to fix that one, an arc from there to fix that one. Then you can take measurements round here. You can draw a baseline round there and take offsets, and you start to build up the drawing. And you've got an accurate shape, an accurate fix to go with. All right? So when we start coming out surveying all this, I'll come along with you, and we'll go through it all again, and I'll show you how to do it and continue it all. All right? So we'll go back up in the office. Well, we'll have a cup of tea because we missed a cup of tea time, and then we'll continue with it all. All right?
Good.
All right. So we take this stuff. Yeah, take all this stuff back in. 15 minutes, something like that. Good enough? Or do you want 20 minutes? You take it from the centre of the instrument.
So hang on, so the 2 readings we're taking in the bottom crosshairs, so 1.41,
0.
1.410, and the top one 1.613, 1.644.
So you got 1644 and then 1.410.
Yeah.
You would end up with 23.4.
So you've added those together.
No, bottom from top times 100.
Hang on. Oh, from.
Bottom from the top times 100. So you get 1644 minus 1.410 gives you
Yeah.
times
I
100.
did the wrong formula.
Yeah. All
I
right.
added them. Bottom from the top.
But you can do it quickly. All right.
Do you know how that gives you the distance?
How do I know?
How does that work? How does that give you the distance?
Because these crosshairs are set at a certain distance, and they've precisely put them when you measure off a staff, it gives you to the nearest 100 mil. And it's simple kit. It's not. But you will then have to measure that on your drawing from this point to there. So you need to know where this is so you can measure from it. So again,
Where would you do the middle?
Well, you'd put a plumb bob on there, so you knew it was on that stone or something. You put a cross mark by a bit of chalk, measure from that station to there, measure from the corner of the window to there, and maybe a third point, the end of the back of path to there.
Yeah.
So you can position that point accurately on your drawing. You know where the level was, you know what the angle is,
Yeah.
and you can level, and then you just draw the angle and put the measurement on. And then you get the level that you've already recorded, which is the middle here. Job done.
Clever.
There's more to this surveying than meets the eye. So their one was within 200 mil, which is a bit much, but
It's not exactly, but it's
It's a little like it should be 23.5.
yeah, that's what we read. But again, the millimetre you can either be over or under, so you could end up with 23.6 or 23.4.
We came up with 24 meters. So.
Well, there's 24s there, isn't it?
yeah.
Yeah.
So we could be.
But that's gone
okay
round
with
the
that.
corner there.
Is it? Oh.
Oh, look at you. Now yank it. Now yank it.
Oh, no, it's probably the zero's not on it anymore.
That's it. Yeah, 23.
23.4 is there.
Yeah.
So it's 100 mil out, which is fine. Right, so we can understand how to level, check the level, and do 3-hair stadia. Now what we're going to do is we're going to get the little optical plummets.
That's right.
Not optical plummet, right angle squares, and we can see how we set out a grid quite easily.
Yeah.
All right. So if we, what's that?
So we've got this level here.
Yeah.
How do we know what the level on the ground? then
Well,
is
you would come
from
up,
that?
right. So if you wanted to establish a height on that station, you would come off your datum point, which could be the floor level of the building. So you'd set your level outside, observe insight as a back sight, observe foresight to there, move your level just on the same place, read that as a back sight, read back into the floor level in the building, add them up. Hopefully we get back sights and foresights as 0. And then you know the difference in the height from there to there. So if that's 10 metres, this might be 9.998 or something. All right, that then is your datum relative to the datum of the floor level.
Okay.
You can then measure off of that, which you start your levelling as a back sight, do a load of levelling, and away you go.
Do you remember earlier you said use the DPC? If you can't.
Well, again, the DPC, if you look at that plinth though, somebody was asking me about plinth. Yeah, the plinth is almost the DPC, it's almost level with the top of the floor.
Yeah.
And what they've done is covered it up because they think it's unsightly, all right? But that basically is the DPC. So again, if you can't see it, but it's almost in line with the floor level, the DPC's in there. So if you use that as your DPC or your floor level, you can then trace it all the way around the building, and you don't have to bother going inside all the time because you've got it outside. All right. The only trouble is if they want to demolish it or change this, they put hoarding around it all, and you can't get access to it all. Then you can't come back to do levelling. You need to transfer that to something, which we've done to a station, and hopefully that'll be outside, and then you can use that and continue doing your work.
Or there's a manhole over
Yeah,
there.
manuals
Do
or
that,
everything, yeah. All right. So again, we're not going to use 3-hair stadia to do the levels here. We're going to use a grid, which is easy to set out, and then you can just move your levels back and forward. So if we put this on here, this is our optical square, right? And in the middle is straight ahead, the bottom one is to the right, the top one's to the left. All right, so if I stick this on here, right, what I'm going to do now is somebody's going to hold 0 on here, yeah, and I'm going to go this way 10 meters or 15 meters or something. Right, so right, that's 10 meters, all right? So I could have levels every 2 meters, I could have a level every 5 meters or whatever else. I now need to make, that's the base of my grid, I now need to put that way. So if you look through there now, you'll be able to see that rod, and I want you to tell me.
Oh, hang on, look for it and see.
No, this is our finished in about half an hour.
Okay. So
What?
we're going to be doing some earthworks.
No problem, we'll be done here in half an hour. So I want you to line me in now. I want you to line me in at 10 meters. So get 10 meters that way, 10 meters this way. Right, which way do you want me to go? Left or right? What you're trying to do is line up the two poles.
Oh, okay.
So you're looking through the middle one to the bottom one.
You need to go that way. That's about it. Oh, a bit more that way. That's it. That's where you were. Yeah.
Yeah?
Yeah.
Right. Have a wee look through that and see if you can line up the two poles.
Am I looking top left or sorry?
The middle
Straight on.
and the bottom.
And the bottom.
The two of them should be in coincidence.
No, I can see where it's- Yeah.
Yeah?
Yeah.
Right, so that's an exact right angle. So you don't have to bother 3, 4, 5 triangle, nothing. Now I'm going to put one along that way
Look at the top.
on a straight line. Now it's easy because I can use that and that one,
You can tell
to get
what's
that
in
one.
Rosemary's jacket if you're looking at the
but you'll get all three of them then lined up.
by the wall, yeah. Yeah.
Yeah, right, excuse me girls. Right, so
You're in charge, so you've got to look at me.
right, so I would measure out here 10 meters. All of them should line up. Or next as mates the difference. No, that's all right, because I'm only demonstrating how to do it. Right? And you can see all three of them lined up.
Yeah.
Yeah?
Oh, I haven't looked. See the three lined up?
Yes, perfect.
How did you do that?
All right, so that is now in a straight line. That's now 90 degrees. I could use the optical square up there, sight that, and put another one over. And immediately or very quickly you can establish a rigid grid. And you can then take levels where you want in between it, measure up with bamboo canes every 2 meters, mark them up in your sketch on your marks, 1, 2, 3, 4, 5, 6, level them all, go back to the office, draw this, level 1 to there, level 2, and quickly you establish exactly where the levels are and what the values are. So it becomes easy. So we've used 3 hair stadia to position it. We've now done a grid and we can position the levels from that. Have you seen the 3 lining up?
No.
And if you set out your bamboo,
Yeah.
and then every time you'd be moving this to each bamboo.
Each side bamboo and write it down, number it,
Yeah.
so you know what level relates to which number. When you process that and go back to the office, you can then just, because you know which way you've done it,
And calling each one.
1, 2, 3, 4, whatever.
Okay. So it's not the same A to B system.
And it will all be as intermediates.
Okay.
And
All right? Because you're not changing on it, you're just observing intermediate shots.
Okay.
so if for example, you were using the GPS in this situation, what readings would you get? So you would stand over there with your
GPS unit.
GPS unit, and then it would give you.
It would give you easterns and northerns and the height relative to the UK grid system or the world.
Okay.
All right.
All right.
And if you were using a detail pole with a glass prism on top of it, and I've got a survey instrument,
Yeah.
it would be a relative distance in horizontal angle and vertical angle from that survey station.
Okay.
It would still need to be processed. All right. Does that make sense? So is it made a wee bit more clearer on some of it? Yeah. But these things are very handy.
Yeah.
They are cool.
They're not, you know, if you're doing, again, if you look at the videos where I swing the tape back and forward to get a right angle, so that you do offsets and you want to know where it is off your baseline. But the further away you can use these, and you know exactly that when you draw it on a plan and you want a 90 degrees, that'll help you get exactly right. So you're not getting things swinging around but it shouldn't be. All right?
Yeah.
So that's about it. As I say, I could lay out baselines and get you to measure some bits off, but again, if you look at the videos and look at the handouts, it should make some sense in how to do it. All right, so that is all about today. So what we'll do is wrap up. We'll get it all back to the office, and that's us.
Thanks.
All right.
Fantastic.
And hopefully I've got a little bit of this video recorded. It switched itself off, so I don't know how much, whether I'm nearly banged in the head.
We'll
Yeah.
reenact it.
God, I hope they weren't watching us.